Yeah, so screen visible है ना? ओके. सो आज हम लाइक अपना न्यू टॉपिक स्टार्ट करने वाले हैं. लाइक कल हमने देखा था मोस्टली डायनेमिक प्रोग्रामिंग. सो हमने कल 2D डीपी देखा था. लाइक 2D मैट्रिक्स पे हम कैसे डीपी यूज करके प्रॉब्लम को ऑप्टिमाइज्ड वे में सॉल्व कर सकते हैं. सो आज हम लाइक आफ्टर डूइंग दैट we are moving forward to our greedy approach. So yeah, yeah. So like yesterday we covered problems like maximal square, then unique paths to and jump game. Uh, ये interesting topics पे थे ये questions. So चाहिए तो एक बार revise कर लेना. So now today we'll start with our day. With this, like we'll go with our first question. That is split with minimum sum. Okay. So uh, what this question states, first we'll see that. So given a positive integer num, split it into two non-negative integers num1 and num2, num1 and num2 such that the concatenation of num1 and num2 is a permutation of num. So, what this sentence means is that we have to form a number will be given to us. Like, see, we'll consider the example here. See, a number will be given to us. We'll need to divide this number into two such combinations that we can concatenate further to receive the sum. And it is mentioned that uh, it won't have any leading zeros. So there won't be any leading zeros. So you cannot add those in your num1 or num2. So what this question state basically is, if we consider it here like 4325. So we need to split this number into we need to split this number into two parts such that num1 plus num2 should be minimized. Okay. So if we consider like uh, 4 if we consider like 4, 3, 2 and 5 separately, like four nums, and dividing it after that in two nums, like it's mentioned here, num1 and num2. So what they have done is, for num1 they have taken 4, 2 from here and 4 from here. So the first num1 becomes 24. And for num2, it's the remaining two numbers are taken, such that their value is smallest among the nums we are taking. So 24 becomes the smallest. We could have taken 23, but why we have not taken it is because if we take 23, the remaining nums would be 50, 5 and 4. So that would make the sum of 45, right? 45 plus 23. That would rightly exceed 59, right? So that won't be our minimum possible solution. So that's why we haven't taken 23 and 45. So what we have done here is we have taken 2 and 4. So it makes our num1 as 24 and num2 as 35. Okay. So let's see other example as well. So what's mentioned, it's same like that. So there are like nums 0, 1 and 2 present. Okay. So we need to divide it in two nums. Okay. So num1 should be like the smallest of the smallest number should be at the tens place. Okay, have you understood this? Like the smallest number should be at the nums place, and the second largest should be at the should form new number if there are three nums. Okay, so and this 8 forms a single digit number. So this makes our num1 as 68 and num2 as 7. Okay, and this their sum would be 75. That would be the optimal sum if we consider any other options like 67, 6, and 7. If we consider 67 plus 8, that would also make the count to 75. So that can be also our option. It would be same only. So either way we are going, the count of the numbers remains the same. So if in this particular example, so now we'll see what approaches we can follow to get our required answer. So firstly, we'll see the brute force approach, how we can like traverse our nums and get our required sum. So what we are doing it is, we are first initializing a num string that would have the value of num. So this would make this num into a string, as we need to in as we need to address every number. So we can't have this as a num. We need it as an array or as a string. You can also convert it in the form of array, as a 1D array. Uh, Here we have converted it into a string, right? So after making the string, we'll see what are the permutations which we can get from here. Okay, so we'll check for every permutation that we can get, like 45, 4 and 5 makes 45, 3 2 32, then 4 4 3 43, 25. We'll take every oth- if we'll consider every available option to get our required answer. Okay, so what we are doing here is, we are calling a function called permutations. So what this is doing, so once we are starting with our first num, uh, then we are adding it in our array list of strings that we are passing it here, right? So this after adding the string in our result array, if the start and the array length is equal, like 4, and there's only one number in the string, then we are returning the sum, and we are returning from here directly, and the count becomes the number itself, sum itself. Okay, so if we consider the num here as 4, the sum would be 4 only, as there are no any other numbers, and we cannot form the sum. Okay, then we'll need a swap function. So how we'll do the swap function, right? So to implement swap, what we do is, we use temporary variables, right? You must have learned that in previous examples, that we assign we assign the temp with the current index, and that index we replace with the index we want to swap with, and that swapped element is it gets the value of temp. Okay, so the values get swapped. Okay, so these functions will be needing uh, in our approach. So what we'll be doing it. is this permute will give us all the permutations that will be performing on the particular string. Okay. So after performing all the permutations, we'll need to find the minimum sum. So how we'll find the minimum sum now? So to find the minimum sum, we'll check for each permutation, which we'll get from here. So if we, sorry, so from each permutations which we have got in this particular function, we'll check for the we'll check for each permutation whether the sum of it is minimum or not. So we are using here uh, loop inside the loop to get the sum of the to get the sum of the two numbers which are minimal and possible. Okay. So if we see this approach, what do you think can be the time complexity of this? Anyone? See, uh, let me give you a hint, like what we are doing. So first, like we are calculating the permutations, right? We are giving the recursive calls for each string element. So it's given for three, it's given for uh, it's given for two, it's given for five. So for each element, we are giving a recursive call. So that makes it to right. What you can think of? You may be wrong. Try to guess. Yeah, it would be n factorial, and not only n factorial, but it would be also be as we are performing the uh, the n n permutations. So it would be n factorial into n. Okay. So as the permutations are performed on each element, so that's n factorial, and we need to traverse the whole string. Okay, that makes our total time complexity to n factorial n. Okay, if we say it, yeah, and the space complexity becomes n factorial as we are storing all the permutations in our list string. Okay, so have you understood this problem? This was an easy one, so I think you must have got this. Okay. So moving on to our next question, that is a task scheduler. So yeah, so that is a task scheduler. Uh, you must have seen the questions like this in operating systems. So it's same like that, but there are some modifications in this. So we'll see our we'll see the question here. So you are given array CPU task. So one array is given CPU task. So each labeled with a letter from A to Z. So the letters which the task array consists of are A to Z, and that is only caps letters, means capital letters. No any small letters are included. And a number n. So, so we'll see forward what n is. So each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals. So, as we can see it here, the tasks which are mentioned, they are need to be completed in the CPU with n intervals. So this is the interval amount of time given to us for performing each task repeatedly. So if we perform A here, we need to perform any other task before performing A again. Okay. So if you perform A, you need to perform B after that, and you cannot perform any other task after that, as there are no any other task than A and B. So you will need to make the CPU idle. Okay, so that would also count. So first we'll go with A, then B, then there would be an idle state where CPU won't perform anything, and then we'll move to A again. Okay, so there are equal number of A's here and equal number of B's. This process would repeat simultaneously. Okay, so after completing task A, you must wait two intervals before doing A again, right? So you will need to perform B, and you cannot perform B again, as there need to be a gap of at least n intervals for performing B. So you will need to keep the CPU idle, and as there are two gaps after performing A, you can perform A again, right? After performing B and idle and A, you can also perform B. Okay, as this satisfies our condition. So that would make so what we need to return as the answer. So we need to return the minimum number of CPU intervals required to complete all tasks. So what total number of CPU intervals will be required to complete the task. We need to return minimum of it. So if we start from A, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this eight CPU intervals are taken. So the output would be 8. So what approach we can follow here is we can first we'll see the brute force one. Okay. So in brute force one, what we can do here is we can simulate all the task scheduling by filling each CPU interval. Okay. So what we do here is we take the most frequency task while ensuring the cooling period n is maintained. Okay, so it tries for all possible arrangements and checks for minimum interval required. If we see the approach here, what it states. Okay, so first what we'll do is we'll take the frequency count of each task that's mentioned. Okay, so here A occurs three times. So the frequency count of A would be three, and frequency count of B would be also three, right? So then we'll sort it according to their count. Okay. When we sort their counts, we'll understand uh, what frequencies we will be needing forward in our example. Okay. So we'll after that initialize max count. After initializing the max, sorry, after initializing the max count, we'll need the maximum frequencies of the particular letter or task, you can say, of particular task. So as there are only 25 letters, as constraints are also mentioned that it's an uppercase English letters. So there will be only 26 possibilities that we'll see. Okay, so max frequency would be count of 25. Okay, so the maximum frequency of the counts would be 25, right? As there can be if there are like all letters present in the task array, so there would be the total total count or maximum frequency of that array would be 25 if we count letters individually and not count their repetition. Okay, so now we'll check if the count which we have got with the maximum frequency. So if we check it like here, we'll check with A with the maximum frequency that is 3. It is less. So we'll increment the maximum count. Okay. Once we increment the maximum count, we'll keep on increasing it uh, until until all the letters are being traversed. Okay. So after getting the max count, we'll implement this formula. So what this formula states is max frequency minus 1. So we are getting the max frequency from uh, max frequency of count of 25, right? So there can be a max possibly 25 different tasks which can be available in the CPU. Okay, so we are reducing it by one and multiplying it with total number of count present, and we are adding max count to it. So why we are adding max count is we need to check whether the we need to check just a minute. Okay, so where we are? Okay. Huh. So why we are adding max count is we need to check if there are multiple entries with the same highest count. Okay. So if like consider here, so there are three uh, three tasks with A letters and B also three. So we need to distinguish between that to make the right choice after the ideal condition. Okay. So that would give us a result array, result integer, and after getting it, we'll compare it with the length of the string. So it should be like greater than the result, like the length we are comparing. So minimum like task which we can get is here is 6, right? So as there are 6 elements, we'll at least get our minimum CPU intervals as 6, right? If we do not consider ideal states, but we'll need to consider the ideal states as we cannot move forward with the gap of two intervals, right? So that was our like brute force approach. We'll see the optimized approach. It's just the same. This that the It's not that optimized, but it's worth giving it a try. So what we'll be doing it is we'll be doing same like counting the frequency of each task. Like here it's A for B. So we'll be counting their frequencies and getting the max one which is present. So here for the for both the for both task A and B, the max frequency is 3, right? So it will this max will become 3. Okay. Then after that we'll be traversing through our count array. Okay. So what this count array specifies is the 26 letters that are present. Okay. So checks with this checks with our current element whether this has already appeared or not, and we keep on incrementing the count as we move forward. So after incrementing, we return the formula which we had derived in the previous approach. So this was the one. So this task dot length. So it's we are considering the length of the string. So we are considering like the maximum of task dot length, which is our whole array, and considering max minus one and into n plus one plus max count. Okay, so this formula which we had derived earlier in our brute force approach, we are using the same to return our minimum intervals. Okay, so the time complexity for this would be like n log n, as we are performing the as we are performing the sorry as we are performing the uh, in as we are performing the am I audible, right? There was a lag. Yes. Okay. Okay. So our time complexity would be m plus k log k. So why it would be k log k? So the sorting that requires within this takes the time complexity of n log n. You can consider it k log k or n log n. We are adding it with this one. So as the addition does not matter, it won't make that much difference. So we are considering this one. Okay. So as we move forward with this one, we'll see our next question. That is add minimum number of rungs. So this is also an interesting like real world problem. So if we go through it, like the problem states is that you are given a strictly increasing integer array rungs that represents the height of rungs on ladder. So what rungs is basically means the step of a ladder, right? So when you say rungs, that is you can consider it like a step of a ladder. Okay, that represents the height of rungs on the ladder. You are currently on the floor at height 0. So you are starting at the bottom and you have a ladder with different distances and you need to reach the top of the ladder. Okay. Top of the ladder means which is the last rung. Okay. You need to reach there and you are also given an integer distance. So you can only climb to the next highest rung if the distance between where you are currently at the floor or on a rung and the next rung is at most distance. Okay. So if we like start from 0 and the distance is 2, then we if the rungs are not present at the uh, 3 or 2 position, then we cannot move forward. Okay, so there needs to be at least a rung at position 2 or 3 to move forward. Okay, so if like you are able to insert rungs at any positive integer height, if the rung is not already there. So if we need to return the minimum number of rungs that must be added to the ladder in order for you to climb the last rung. So what we'll be doing it is, if we see the rungs array, we are first at the rungs I. So that is we are at the first rung. We can travel at the distance of 2. So as there is a rung present at 3, so we can step on it, right? Okay. So 1, you can travel from 1 to 3. Then the distance is 2 mentioned. Okay. So the distance is 2 mentioned. So you can also go from 3 to 5. Now there's a twist. Now the rung is directly at the 10th position and the distance given is only 2. So you cannot move 5 to 10, okay, directly. So what you will need to do is you will need to add the rung at 7 and 8. So why you will need to add at that particular position only? So like if you add at like if say 6, wait, consider if you are adding it at 6 and after that we'll need to travel again two more distances. So after adding 6, we'll go to 8, right? So we'll also need the rung at 8th position. So we'll need there as well. So that will increment our count to 3 and 4. Okay, but we need to return the minimum number of rungs that are required. So what we'll do is we'll add a rung at 7. So what this will do is we'll travel 2 steps, and after traveling 2 steps we again need to reach to 10. So after 7 there's we can add at 9, or we can do it what we can do it here is we can add at 8. Okay, so that both options are valid. You can add at 7 8, or you can add at 7 and 9. Okay, so once you add at 7 and 9, you can reach our final destination, that is 10. So that we need to return what minimum count is required to reach the last term. Okay, so first we'll see the brute force approach required for this. Wait. Okay, so in the brute force approach, you will check the gap between the first and second element. So if it's like less than the given distance, you can move forward, or if it's greater than the distance, uh, then only, but it should not be less. Okay, so once like you will need to count how many additional rungs are needed to bridge the gap. The number of rungs is determined by dividing the gap by distance and subtracting one as the original rung is already there. Then use some of the additional rungs needed for all such gaps. So what you do is you go from 1 to 3, what we had done previously. So there's distance of 2. So what is the maximum distance provided? Will travel to that much distance. Okay, so that is 3. So once we reach 3, we'll then again go to distance 5. At the maximum distance we can travel is 2. Then after moving till 5, we'll move again to 7. And then 7 to we can move to till 9. And after 9 to reach 10, we need just one step, like one run. So uh, that we can do, as the maximum number of rungs we can pass on is 2. Okay, so let's see the code implementation of this. So we'll assign the count variable, which will count the gap and the number of rungs that are to be added. So if we consider like our what was our previous height and compare it with rungs of I, 3 minus 2, we'll get the distance between this. Okay, and if the gap is smaller than the distance, we'll take the summation of gap minus 1 divided by distance, and we'll be adding it with our previous count. So after this we'll, after this in the array, we'll need to update our previous height, that is if we consider it here, so it will be like become 5 plus gap is 2, right? So 2 minus 1, 1, and divided by distance, that is 2. So uh, it will become 3. Okay. So after, and we'll need to update this to the rungs of I. Okay. So as we are performing the calculations again, we'll need our previous height. Okay. So after calculating this repeatedly, we'll ultimately reach our end, and as we are incrementing the count as we reach, then we'll return the count once we reach our final goal. Okay. So that's our brute force approach. Uh, Again, in this one, we are already using the greedy approach. So how we are using that? So for we are not considering the consequences for this one, like whether after 3 there would be 4 or 5. We are not considering future consequences. We are just making a criteria that if the gap is smaller than the distance, then we are traveling through it. And based on this criteria, we are moving forward. Regarding if we don't consider any consequences for it. So this will reduce our time complexity to the big of n, okay, and also the space complexity to big of 1, as we are just storing the extra space, constant amount of extra space. Okay, so if we see the single pass approach, like uh, it's just the same. There's no any difference, but you can, like, this is only the optimized approach. What you can do here is, if such questions are like asked in an interview, so first go with all the all the heights you can climb this ladder to, like 1 to 2, then 2 to 3, then 3 to 4, 4 to 5, 5 to 6, 6 to 7, 8, 9, 10. So that would be like the maximum count you will require, right? So after getting the maximum count, you will keep on checking it with the count you will get it after implementing the distance one. So after getting the distance one, you will see that the number of rungs required will be keep on reducing as you move forward. Okay, so as you will move forward, the number of rungs will eventually decrease. So the maximum number of rungs that are given, you can uh, update it with the previous minimum you have got. So if we consider it here, so we have got here maximum like 1, 2, 3, 4, 5, 6, 7, 8. So you have got here 8. So you will update it once you get like 1 to 3, 3 to 5, 5 to 7, 7 to 9, 4. So you will update it with 4. Then after traversing for two distances, you will see that the you will need to find the minimum of 2 and 4. So that would be 2 again. So but this would make the time complexity too big of n square. So that won't be an optimized approach. But what we have currently seen is an optimized approach. While moving forward in an interview, always go with the brute force approach first, and then go with the optimized approach. So the interviewer will see that whether you are able to break down the question or not. So like if you have also previously seen that question, still, like you are directly reaching to the final goal, the interviewer will understand that, and he won't be that much happy to see your solution. But if you like break down the problems into smaller parts and then try to solve it by step, so the interviewer might select you for that particular round. Okay. So if you have any doubt, you may ask. Okay, so the questions covered were today were also important, like the yesterday. So this, like the greedy and the dynamic programming, these two main concepts are mostly asked in interviews. Like if you like solve the weekly contest and all, you must have seen that there's every single time there's one dynamic programming question. So if you like go into competitive programming, you will need to understand dynamic programming and greedy very well. Okay, this might look somewhat hard, or will need some time to understand. But if you like practice more enough, you will eventually understand all the topics. Okay, so that's it from my side. Uh, Anyone wants to add anything? Okay, so we'll stop here. Okay.